Welcome back to Algebra 1 Honors. This is part 2 of Lesson 5-13, using factoring to solve word problems. And this is a very common type of a problem. This one happens to be a picture, the red, surrounded by a border, a frame, the blue. But you might see it as a garden plot surrounded by a path, or a pool, a swimming pool, and this is the walkway around it. Okay? So this problem comes in a lot of different formats, but the way you do it is very similar. Okay? So it says a picture is 10 inches longer than it is wide. So length is width plus 10, width is just W. Okay? And a border is put around, and the border is 5 inches. It's a uniform border all the way around. So that's why I've got the arrows with the 5s. Okay? And the area of the border, too many words here. The area of the border is 400 inches squared. And we want to know how big is the picture. What are the dimensions of the red rectangle in the middle, the picture in the middle? Well, this is a problem of calculating the difference between two areas. Okay? You want to find the area of the big blue rectangle. So imagine the red rectangle wasn't even there. Okay? You want to find the area of the blue rectangle minus the area of the little red rectangle. Because if you take the blue rectangle, okay, and you imagine taking a scissors and you cut a hole in the middle, you cut out the red rectangle, what's left is just the border, right, the area of the border. And they tell you that the area of the border, just this part, is 400. So if you can take the whole blue rectangle's area, subtract the red rectangle's area, you're left with 400. So it's a very simple problem now. How do we find the area of the blue rectangle? We have to have its dimensions, its length and its width. Well, the red one's actually easier to write its dimensions originally. It's W and W plus 10 go in this way. So the area of our red rectangle, our picture, is going to be W times W plus 10. Okay, that's the area of my picture itself. Now, how do we find the area of the blue rectangle? Well, we have to come back over here and look. From here to here, the area of the red rectangle, or the width of the red rectangle, is W. So from here, the red corner to this red corner is W. Plus, I'm going to add another 5 inches here and another 5 inches there. So the length of the width of my blue rectangle is going to be W plus 5, which is W plus 10. Okay, now how about the length? The length of the blue rectangle. Well, from here to here, we already know is W plus 10. I add another 5 here and another 5 here. So W plus 10 plus 5 is W plus 20. So going down this way, the length of our blue rectangle is W plus 20. So our area is going to be W plus 10 times W plus 20. The area here minus the area here equals 400. Okay? And now we have an equation that we need to do some multiplying and distributing and solve. I'm going to erase my rectangle over here so we have some space. We're going to first FOIL W plus 10 times W plus 20. And we're going to get W squared plus, 30W plus 200. Okay, and then we're going to subtract from that the area of our red rectangle, which is W squared plus 10W. Okay, and that has to equal 400. So now we have W squared plus 30W plus 200 minus W squared minus 10W equals 400. Well, let's see, W squared minus W squared, that term disappears. 30W minus 10W, we have 20W left. And then plus 200, and we want to subtract that 400. So let's bring the 400 over here. So 200 minus 400 gives us a minus 200 equals 0. Now we have to factor. We can take a 20 out of both of these. Factor out a 20, we get W minus 10 equals 0. Divide both sides by 20, we get W minus 10 equals 0. Add 10 to both sides, we get W equals 10. Okay? So, how big is the picture? The picture was W by W plus 10. So, W is 10 by W plus 10 is 20. Our picture was 10 inches by 20 inches. Okay? But again, the way to do this problem, or anyone like it, is as the difference of two areas. The area of the larger rectangle minus the area of the smaller rectangle gives you the area of the border. Okay, now they might phrase it a little differently. They might write the numbers a little differently. But that's the general idea for how to use factoring to solve this kind of a word problem.